So what we're starting with is the imaginary numbers. Have you guys ever dealt with the imaginary numbers at all? Usually you haven't at this point, but sometimes I get that stray person that knows what I'm talking about. The imaginaries came about because we have problems like x squared plus 1 equals 0. And last week, when we were solving problems like this, where we're using the square root to solve, we would start by isolating this x squared, right? Where I'd go -1, -1, and we would get x squared equals -1. And then we would take the square root of both sides, right, to solve it. And we would be left with x equals a plus or minus something. And we would go, well, what times itself can equal this number under here? Can anything times itself equal -1? Is there a number in existence that if I multiplied it times itself, it would equal -1? The no's have it, right? If I multiply -1 times -1, I get +1. If I multiply 1 times 1, I get 1. No number multiplied times itself can produce a negative number. And so the way mathematicians went about solving this problem so that we weren't at a complete standstill, they came up with what we call the complex number system. And we're going to get more and more into the complex number system as we go. But today we're just starting with dealing with pure imaginary numbers. And when we're talking about pure imaginary numbers, we are saying that we have this imaginary unit that we call I, and I equals the square root of -1, right? I squared, we say, equals -1. This right here, this little bit of information is the most important thing that you will learn today, right? If you understand this piece right here, that I is what we call imaginary, right? I is our imaginary number. Equals the square root of -1. And that if we multiply I times I, we get -1. And we don't question why, because it's sort of made up and contrived by mathematicians. Really, we just take it at its face value. Then you will do well in today's lesson. And nothing beyond this will be all that difficult today, right? But if you struggle with this little piece right here, today will be really hard. If you're like, man, why? Well, why? Because we made it up. That's why. So if I look at this now, I could go, okay, well, this just equals plus or minus I, right? When we're dealing with imaginary numbers and we get anything of the form bi, that doesn't spell by, it means b times I. B is our real number. That does not even look like the letter N, does it? No, it doesn't. It looks like a W. That's terrible. You know, it's Monday for me too. B is our real number, and I is the imaginary component. We call this a pure imaginary number. Anything with a real number and an imaginary number we call pure imaginary numbers. Next week when I see you, because I'm not going to see you on Thursday, we'll get into complex numbers and how they all fit into a system, and we'll get into the craziness of that. But for the most part right now, we are only today dealing with the pure imaginary numbers. When we're simplifying negative square roots, which is basically what the whole idea of imaginary is, we are going to follow a few steps. I like steps. Simplify negative square roots. Number one, we are going to rewrite history. Not really, although people are trying. Negative a, so negative whatever is under the square root, as negative 1 times a. That doesn't even look like an a, it looked like a 9. Number two, we are going to break down a in its simplest form if it's not a perfect square. Break down a if it is not a perfect square. Just like we did last week when we were dealing with square roots, right? We would break them down to their simplest form. Once we pull that I out, it's just a square root, and we deal with it just like a square root. Number three, simplify the radical. Recalling that the square root of negative 1 equals I. Right? Now, me, when I do it, I tend to just pull the I out first, pluck out the I, and then deal with it. But I like having steps to refer back to, so we can use the ones provided. But let's look at it in terms of examples, because everything is always easier to see in terms of examples. If I have the square root of negative 9, and I look at that, I could rewrite that as the square root of negative 1 times 9, right? When I pull that out, I would have, well, the square root of negative 1 is I, and the square root of 9 is 3, and it would be 3I. Now, a lot of times when I look at problems like this, I could go, okay, well, here I've got the square root of negative 196. I automatically, when I do it, just pluck out the I times 196, and then I just deal with it as a positive square root. It is your choice whether or not you want to do it this way or that way. I like to just get the negative out right out off the bat. 196 is 14 squared. It is 14 times 14. So this would become plus or minus 14I. Right? That's how we deal with the negative. We just pull it out as an I. We pluck the I out, which sounds violent, but works anyways. They're not always going to be perfect squares, though. Just like last week when we were dealing with these, not all of our square roots were perfect squares, and we still have to simplify them. So if I have, say, the square root of negative 32, when I look at that, I go, okay, well, that's plus or minus I times the square root of 32. And I have to break that 32 down, right? I know, because I'm super smart. No. I know that 32 breaks down as 2 times 16. And I can see that 16 is a perfect square, right? It's 4 times 4. So this can come out as plus or minus 4i, but that 2 that doesn't have a perfect square to it would have to stay underneath, right? So this is just like last week once we pull the I out, right? We're doing the same exact thing we did last week when we were solving these square roots, only now we have to take out that I component, that negative component, so that it's solvable. Does that make a little bit of sense? I see a nod from Madison. I see a nod from Shaylin. So that means everybody's good, right? Because nobody's telling me no. Sure. Valerie's good. All right. We're not always going to get these perfect squares. Last week we were using them to solve equations, right? We were taking the square roots to solve quadratic problems. And so we're going to be doing that a little bit today too. So we're going to have problems like x squared plus, x squared plus me not being able to write. That was getting totally dyslexic there. I was writing 18, but trying to write 81 equals 0, right? When I wanted to solve this last week, we would start by getting this x squared isolated. So I'm just going to subtract 81 from both sides. And I wind up with x squared equals the negative 81, right? And then if you remember correctly from last week, once we get this done, we can take the square root of both sides to find our solutions. And in this case, we're going to be left with x equals, well, here I have negative 81. So this would be plus or minus I times the square root of 81. What is the square root of 81? Does anybody know? Is it a perfect square? $1 million imaginary dollars, if you know this. You could be imaginary rich, which is only fitting because we're talking about imaginary numbers. Right, it's 9. So we are going to have plus or minus 9i. This is what x equals. Why plus or minus? Because 9i times 9i can equal negative 81, but also negative 9i times negative 9i can equal negative, or can equal positive 81i, which is the square root of negative 81. What about when they're not perfect? What if I've got 4x squared plus 15 equals negative 19, right? We're going to do the same work. We're going to move everything over. We're going to start by subtracting 15 from both sides, and we get 4x squared equals negative, what's that? 24, 34? What is it? 24. Oh, this was supposed to be negative 9. I'm like, why is that 34? That's my bad. This is supposed to be negative 9. I don't know why I wrote 19. It looked like a 19, I swear. Then we're going to divide by 4. Divide by 4, we get x squared equals negative 6. Negative 6, I can already tell you, not a perfect square, right? Because we know our perfect square is 2 times 2 is 4, 3 times 3 is 9. 6 lies somewhere in between those. We know it's not going to be perfect. We're still going to go for it. Here I've got x, whoops, sorry, not x squared, x equals the square root of negative 6. So we could start by saying plus or minus I times the square root of 6. Does the square root of 6 break down? No. So this is our solution right here, right? We can't break down 6. Nothing's going to come out of that 6. It's 2 times 3. There's no pairs in there that we can pull out. Ultimately, Jameson, yes, you absolutely just once if you have a negative under a square root, pull it out as an I and then solve it like a regular square root. You're exactly right. The negative comes out, it becomes an I on the outside. And then it's just a square root. If I have x squared plus 13 equals 1. I'm going to subtract 13 from both sides, right? And I get x squared equals negative 12. And when I take the square root of both sides, ooh, very Halloween colors there, I wind up with x equals the square root of negative 12. And when I start with that, this one's going to break down though somewhat. I'm going to have plus or minus I here times the square root of 12. And if we deal with this 12, we can't leave it like this. If you get this far on your homework, I'm like, oh, cool, that's awesome. But you can't really leave it like that. We have to look at 12 as maybe 3 times 4 or 2 times 6, which is then 2 times 3. But we know that this is a perfect square we can pull out. And so we get plus or minus 2i, and then back underneath has to go that 3 that doesn't have a pair, right? That's not a perfect square. So that's a little something to play with. Next, this is my favorite part. I used to offer this part as an extra credit thing for anyone who could come up with an algorithm or an equation to find the next one, but I don't have enough people who actually participate in it to make it worthwhile in doing it. But we're talking about the powers of I. Right? If we look at I to the first power, well, that just equals I, right? I times nothing. I to the second power, if you think about it, that's I times I, which we have already discussed is negative 1, right? I squared equals negative 1. Well, I to the third power then would be negative 1 times I, right? Think about that. I to the third power, if I times I is negative 1, times another I just becomes negative I. I to the fourth power, well, it'd be taking negative I and multiplying it times I. So if I multiply negative I times I wind up with negative I squared, right? Equals negative I squared, but I squared just equals negative 1. So that would be like negative 1 times negative 1, which just equals 1, right? If I do I to the fifth power, we're saying 1 times I. Well, again, that's just I. I to the sixth power, we're taking this I to the fifth and multiplying it times I, which is negative 1. I to the seventh power. What's I to the seventh power? I to the seventh power is taking I to the sixth power, multiplying it times I, and we get negative I. I to the eighth power, we're taking negative I and we're multiplying it times I, and we get 1. And we could keep this going. I to the ninth power would go back to I. I to the 10th power would be negative 1. I to the 11th power would be negative I. I to the 12th power would be 1. Does that make sense? There's a pattern. So let's look at how we can figure out what is I to the 107th power. I do it by dividing 107 by 4. So let's look at this. If I divide 8 by 4, right? Here we have I to the 8th power. We already know what I to the 8th power equals, right? If I go 8 divided by 4, I just get 2. No remainder, right? It's an even 2. This becomes 8. We have a 0 remainder, right? Anytime we have a 0 remainder, it's going to be 1. Anytime we have a remainder of 1, it's going to be I. Remainder of 2, remainder of 3. Right? So think about this. If we look at 107, well, I go, okay, well, 4 goes into 10 2 times, and I get 8. And then I'm going to have 27. 4 goes into 27 6 times, right? Which would give me 24. And I have a remainder of 3. So I to the 107th power equals negative I. Right? And we could do this all day long, right? I to the 203 power, right? I'm just going to go 203 divided by 4. Well, 4 goes into 25 times, and I get 0 remainder, but 3 down here. 4 doesn't go into 3 at all, so I get a remainder of 3, right? And so I would wind up with 50 with a remainder of 3, and a remainder of 3 gives me negative I. Kind of cool, right? That's why I like it. Except for I messed it up this morning, so I can't hold that against them. That's what happens when I have an 8 a.m. class. Sometimes I mess stuff up. Last bit. Products of imaginary numbers. Multiplying imaginary numbers together. Products always means multiplication. I'm using a lot of this purple pen today. If I have 4i times 7i, I get 28i squared, just like if I was multiplying any variable, right? But we know that I squared equals negative 1, right? If you remember, I said earlier, the most important thing we would learn today is I squared equals negative 1, and I equals the square root of negative 1, right? So this is like saying 28 times negative 1, which equals negative 28. If I have negative 4i times 2i times negative 9i, right? Well, I go negative 4 times 2 is negative 8. Negative 8 times negative 9 is positive 72. So right now I'm at 72i times I is I cubed, right? What do we know I to the third to be? Well, we can go up and look at it, right? And see that it's negative I. I heard you. I saw you get that. So what we have here is 72 times negative I, which is just negative 72i. Right? What if I have two I cubed times 5i, right? That is like saying 8, 2 times 2 times 2 is 8, I cubed times 5i, which gives me 40 I to the fourth, which gives me 40 times, if you remember, I to the fourth just equals 1, which just gives me 40. Make some sense? So nothing on this is super difficult. There's nothing we're doing here that's really, really difficult, but it does take some practice because it's very new, right? If I have the square root of negative 18 times the square root of negative 10, what happens when I multiply those together? I'm going to have I times the square root of 18 times I times the square root of 10. And if I multiply them together, I get I squared times the square root of 180. Right? And then I can break down the 180, which, let's see, 180 is 36 times 5. If you don't know what 180 is, then, start with 2 and work your way down. But I know that it's 36 times 5. So if I look at this, I have plus or minus 36 is a perfect square. 6i squared times the square root of 5, right? Because I got to put that back under. What is I squared, though? -1. So this becomes -6, right? Because if you think about it, that's -1 times 6 times the square root of 5. Now, if I have the plus or minus, do I even really need the -6? No, but keep it in there anyways. But I always like to take the I out first because then I'm just dealing with a square root. Some people do like to break it down, right? They like to do, wow, that's all the way back in the beginning. I didn't realize we wrote that much. Some people do like to break it down inside where they can see the -1. To me, I just go pluck the I out. The minute I see a negative under a square root, I take it out as an I, because then I don't have to deal with it anymore while I'm breaking down the square root. To me, it's just easier to have it out of the way. This is as far as we're taking it today. There will be a worksheet. I haven't posted it in PowerSchool yet, but as soon as I get rid of you guys, I am going to put it into PowerSchool as a PDF. It is the only assignment you have this week, so I'm making you do all of the problems. Normally I don't, but they're very fast problems. None of them are super time consuming, and I would rather you guys have the practice. Does anyone have any questions regarding any of this? I know we covered a lot of different facets of the same thing. If you're working on it and you do have questions, message me. I will find some time. We can go into a meet and answer any of those questions. If you want to, save them for the next time I see you. We can talk about them in the beginning of class the next time I see you. The next time I see you, we're going to be delving further into the complex number system. So it will really help if you get this done before the next time I see you. So it's almost helpful that I won't see you on Thursday as far as starting the next lesson, because I know that your homework will have been due by the time next time I see you. So most of you hopefully will have completed it by then, because practice is super important in all of this. Okay. Sometimes it's hard to know what you don't know until you give it a shot. All right. So I am going to end the video now because there's no reason for me to keep recording any more of this.